Hey guys, welcome to my channel. When you think of infrastructure in the United States, the first things that probably come to mind are the iconic orange-red cables of the Golden Gate Bridge or the endless stream of cars on the interstate highways. These are, without a doubt, symbols of American pride. After all, the Golden Gate Bridge was completed in 1937, and the Hoover Dam stunned the world way back in the 1930s. But today, let's shift our focus halfway across the globe, to China. There, a groundbreaking infrastructure revolution is unfolding, one that is redefining the scale, the speed, and the technological limits of what we once called engineering marvels. This is the story of China's infrastructure, a story of breathtaking ambition and record-breaking projects, of a nation reshaping its landscape at lightning speed and rewriting the global playbook for what infrastructure can achieve. Can you believe this? While America is still stuck in endless debates, just to renovate a single bridge, China has already built the tallest bridge on Earth, suspended between cliffs as high as a 200-story skyscraper. While American high-speed rail proposals are still stuck in Congress, China's bullet trains are racing at 421 kilometers per hour across a staggering 40,000 kilometers of high-speed rail, more than the rest of the entire world combined. This isn't a sci-fi movie. This is real. This is China, redefining what's possible in engineering, one mega project at a time. High up in the sky, the elaborate network of atmospheric circulation delivers water vapor from the four oceans continuously into China. Like rivers in the sky, they descend to Earth and become the 45,000 rivers that run and rush across the nation, bestowing China with one of the most dense river systems and the most diverse landscapes in the world. Let us begin with the Yangtze River, China's longest and also the largest by volume and watershed area. Its annual runoff accounts for 36% of China's grand total, equivalent to that of 17 yellow rivers combined. During flood seasons, the maximum runoff can triple its normal. If this imposing volume of water is not handled properly, a catastrophe awaits. If only there were an enormous pond that could store all the floodwater. There it is. What you see now is the largest reservoir ever built in China, the Three Gorges Reservoir. The Three Gorges project is one of the world's largest water control systems, about 2,335 meters long and 181 meters high. It integrates flood control, power generation, and navigation. It can store enormous flood volumes, supplies world-scale hydropower capacity, and lowers the difficulty and cost of shipping on the Yangtze. The project has sparked debate over resettlement and environmental impacts, but its strategic role in flood mitigation and energy security is substantial. With a storage capacity of up to 45 billion cubic meters, it can swallow more than 3,000 West Lakes. But this is still not sufficient. When you look at the entire Yangtze River, you will see in the upper mainstream the four cascade reservoirs known as Xiangjiaba, Siluodu, Baihetan, and Wudongde, and Tingziku, Gupitan, Ertan, and Jinping in the tributaries. Over 50 large reservoirs now guard the Yangtze watershed. In terms of water storage capacity, we have virtually built three more Three Gorges Reservoir. Every year before the flood season arrives, reservoirs empty part of their storage in preparation. The emptied volume is called the flood control capacity of a reservoir. When floods arrive, it is used to retain excessive water behind the dams. This prevents flood peaks from hitting the downstream simultaneously and compounding the risk. Meanwhile, the retained floodwater is released downstream in a managed way so that flood peaks are either reduced or delayed. This ensures safety in the downstream. The entire watershed is also under the surveillance of more than 30,000 monitoring stations and meteorological satellites that relay precipitation and water level data in real time. They provide scientists with precise rainfall and flood data, which enable unified scheduling of the reservoir cluster. The South to North Water Diversion Project is China's largest water transfer undertaking, divided into eastern, central, and western routes. The central route starts at the Danjiangkou Reservoir and runs about 1,432 kilometers through Henan and Hebei to Beijing. Rather than simply pumping water uphill, the project uses gravity-assisted channels, aqueducts, and tunnels to move southern water north. Completed over many years and involving the relocation of hundreds of thousands, the central route has delivered hundreds of billions of cubic meters of water by 2023, serving well over 100 million people and securing water supply for northern China. That equipped the entire route. This grand project is able to navigate through 8 provinces and 4 major river basins, diverting water over 2,000 kilometers cumulatively in an orderly manner. 9 years into its full operation, water sufficient to fill up the entire Yellow River has been diverted to North China, meaning that 170 million people in 44 cities now use water from the Yangtze River. Today, empowered by modern technologies, China is reshaping rivers like never before, and even create new rivers on this very ancient land. This is the Taihang Mountains. Hanging along the cliffs are not just roads, but also a river. It is the Hongxi Canal that diverts water to Linzhou in Henan province. Chronic droughts pushed the Linzhou people to hammer and carve this 70-kilometer-long waterway up high with bare hands and very basic tools. But 70 kilometers, it is barely a dot on the vast expanse of China. The temporary reservoir you see now are all man-made. China has more abundant water resources during summertime, and the vast of them belong to the southern regions. These artificial rivers are designed to break this extremely uneven distribution and restructure water allocation in China. Yet, creating artificial rivers puts man at the trying test of nature. In Shanxi province, a 98-kilometer-long tunnel penetrates the Qinling Mountains and diverts water from the Hanjiang River to the densely populated Guangzhong Plain. In Gansu province, water from the Yellow River traverses the desert, nourishing a string of oasis cities and resisting the expanding desert. The Hong Kong-Zhuhai Macau Bridge spans roughly 55 kilometers and links Hong Kong, Zhuhai, and Macau. It's a highly complex maritime project that combines bridges, artificial islands, and an immersed tunnel to protect shipping lanes and sensitive ecological zones. Gigantic immersed tunnels were precisely installed with millimeter-level alignment, and the project used hundreds of thousands of tons of steel. Once opened, travel times between the cities dropped from hours to mere minutes, greatly advancing regional integration. China's high-speed rail network leads the world in scale and density, with over 40,000 kilometers of lines linking major cities into a high-speed web. With 40,000 kilometers of operating lines, far exceeding the total high-speed rail mileage of all other countries combined, this network tightly links more than 100 cities, serving a population of over 1 billion. Every year, it connects trillions of dollars in economic activity. Trains such as the Daxing operate at several hundred kilometers per hour with remarkable stability, punctuality, and comfort. From ice-covered plateaus to tropical islands, this vast network operates at high speed every single day. And thanks to China's efficient, rapid construction capabilities, it is constantly expanding. This is one of the most ambitious mega-projects ever undertaken by the Chinese people. And it's not the end, but just the beginning. Even more importantly, the core technologies of high-speed rail have been fully developed and industrialized domestically. China's standards and equipment are now being exported abroad, playing a growing role in high-speed rail projects worldwide. The Sichuan-Tibet Railway crosses high plateaus and active fault zones, one of the planet's most challenging rail routes. It traverses snow peaks, deep gorges, and unstable geology, confronting high altitude, thin air, and extreme weather. Construction required precise tunnel boring, aerial bridge assembly, and plateau-specific techniques. Landmark structures like the Yarlung-Zangbo River Bridge were erected with helicopter lifts and millimeter-precision steel assembly. Beyond connectivity, the line carries strategic and vital civilian importance. Starting from Tiananmen Square and moving 46 kilometers south along Beijing's central axis, a brand new world-class landmark has risen, the Beijing Daxing International Airport. Together with Capital International Airport, it forms a dual-hub system, providing powerful support for the coordinated development of the Beijing-Tianjin-Hebei region. From a mega-engineering project to China's new national gateway, Daxing Airport has always been in the global spotlight. In 2016, it was named the #1 of the 7 new wonders of the world by The Guardian. The terminal complex covers an astonishing 1.4 million square meters, equivalent to 3.2 Tiananmen squares. Today, it has become one of the largest aviation hubs on the planet. Beijing Daxing International Airport, shaped like a phoenix, features an enormous single terminal designed for efficiency and passenger convenience. Seen from the sky, this airport is already breathtaking. The entire terminal radiates outward in 5 concourses, resembling a phoenix spreading its wings. With a total floor area of 1.4 million square meters, equivalent to 63 bird's nest stadiums, it is one of the largest single-structure terminals in the world. Its main roof is made up of more than 8,000 irregular curved glass panels, a construction challenge that was nothing short of hell level in the world of architecture. But what's truly remarkable is its efficiency and design philosophy. From security to the farthest boarding gate takes only 8 minutes on foot. It is also the world's first integrated transportation hub, combining high-speed rail, metro, intercity rail, and express lines all beneath one roof. Add to that a fully automated baggage system, intelligent navigation, paperless boarding, and facial recognition, and passengers here hardly feel the weight at all. One detail during construction left a lasting impression. The central hall's ceiling houses a dome of light, illuminated entirely by natural sunlight during the day, both energy-saving and visually stunning. Installing this dome was an extreme engineering challenge. Workers stood on scaffolding dozens of meters high, piecing it together millimeter by millimeter. And yet the entire civil construction of the airport took only 4 years. A feat hailed globally as a miracle of Chinese speed. With its completion, Beijing entered the era of dual airports, boosting its annual passenger capacity to 100 million. More than just an airport, this is a super gateway connecting China to the world, and a powerful symbol of China's modernization. To bridge spatial gaps between energy resources and demand, China built UHV transmission lines that move large amounts of clean power over great distances. Projects such as the Changji-Guquan 1,100 kilovolt DC line span thousands of kilometers and transmit tens of billions of kilowatt hours annually. With tens of thousands of kilometers of UHV lines, China now networks wind, solar, and hydro generation into major eastern population centers. Beidou is China's independently developed global navigation satellite system. From its inception in 1994 to global coverage in 2020, Beidou now operates dozens of satellites worldwide. In many scenarios, it outperforms standard civilian GPS, with meter-level and in some cases centimeter-level accuracy. It also supports short message services, precision timing, and global search and rescue. Beidou has proven critical in rescue missions and industrial applications, is part of international GNSS interoperability frameworks, and is increasingly offering services globally. In the future, every frontier of technology, autonomous driving, the Internet of Things, smart cities, intelligent manufacturing, and civil-military integration, will rely on pinpoint positioning, flawless timing, and unshakable navigation. At the heart of it all will be Beidou. High above us, across the boundless expanse of space, it has woven a precise and intricate web of stars, linking Earth to the heavens with invisible threads of light. Beidou is more than a triumph of engineering. It is a gift from Eastern civilization to this era, a coordinate in time and space that will guide the world into the future. In the digital age, 5G base stations, data centers, and the national internet backbone are the new infrastructure. China rapidly deployed millions of 5G sites, rolled out East Compute, West Store, and scaled IPv6 adoption. This digital backbone supports autonomous vehicles, industrial IoT, smart cities, and digital payments, an invisible but critical network that powers modern life. When you think of a desert, what comes to your mind? Endless sand? Scorching heat? No signs of life? Well, where deserts are not dying. The Taklamakan Desert, China's largest desert. For decades, its sands crept outward. Homes, roads, farmland, all lost to the wind. That story is changing. After 40 years of effort, China has built a 3,046-kilometer greenbelt encircling the desert, the longest man-made desert shield on Earth. It doesn't just stop sand, it's helping lift people out of poverty. So how did they do it? First came the basics: roads, irrigation systems, power grids. In 2024 alone, billions were invested in Xinjiang's desert control. Then came 3 models. Model 1, engineering. Lattices of straw checkerboards are laid across the dunes. They break the wind, slow the sand. On the edges of the Taklamakan Desert in Beidou County, factories produce reed mats in weaving machines, a faster process and a more durable product, and a new income stream for locals who install them. Model 2, biology. Drought-resistant plants take root in the sand, and hidden beneath some, a desert herb called Cistantia deserticola, nicknamed the ginseng of the desert. To grow the herb, you must grow the sand-fixing plants first. Ecology and economy intertwine. To scale this up, the government offered incentives for companies and farmers to lease desert land, turn it into farmland, and grow sustainable industries. Model 3, solar power. This desert gets endless sun, which is perfect for solar farms. In Shaya County, 540,000 solar panels generate clean power, enough for the needs of 430,000 people a year, while anchoring the ground against erosion. Some regions have gone further by turning the desert into a destination. Macau County saw 500,000 tourists last year, creating jobs and boosting the local economy. And this is just the beginning. By 2030, Xinjiang plans to restore even more arid land and build a full industry loop, linking solar power, eco-agriculture, and desert tourism. The projected annual value? Over $1.4 billion. Over the past 4 decades, generations of desert fighters in China have discovered a powerful truth, that within the shifting sands lies a path, from retreat to resistance and revival. The 3 North Shelter Belt program began in 1978 and is one of China's largest, longest-running ecological restoration efforts. Aimed at halting desertification and protecting farmland, it has planted billions of trees and restored tens of millions of hectares, taming sandstorms and transforming regions over generations. Its value is quiet but profound: ecological security and improved quality of life. Beyond the projects above, China has world-class achievements in energy and science. For example, the Baihetan hydropower station is among the most complex hydropower hubs, with massive generating units manufactured and installed to micro and sub-millimeter tolerances, showcasing expertise in large-scale precision machinery. And FAST, the 500-meter aperture spherical telescope, sits in a karst sink and offers sensitivity multiple times that of earlier giant telescopes, used for exoplanet searches, pulsar studies, and dark matter research. Together, they illustrate China's integrated strength across energy, science, and infrastructure. These projects are no accident. They combine national planning, large engineering workforces, integrated supply chains, and sustained R&D. Unlike countries that stall on approvals, financing, or local disputes, China's system can concentrate resources and execute major projects quickly. China now exports this capability through overseas contracting and cooperation, reshaping parts of the global infrastructure landscape. Infrastructure is more than steel and concrete. It underpins national competitiveness, improves everyday life, and invests in the future. Over recent decades, China's engineering projects have reshaped geography, sped up economies, and broadened social possibilities. As an old Chinese saying goes, to get rich, build roads first. Indeed, transportation is the cornerstone of economic development and a crucial guarantee. Prosperity can only come when people and goods can move smoothly. Engineering and technology are forces that reshape the world, accelerating the wheels of history and fueling the progress of human civilization. Today, as China rises to become the world's second-largest economy and the leading manufacturing powerhouse, it is also proving its extraordinary engineering capability, gaining global recognition as an infrastructure giant. A series of breathtaking mega-projects has showcased China's national strength and vitality to the world. Amid global economic shifts and China's new stage of development, these projects, defined by their massive scale, technical complexity, enormous investment, and long-term impact, span transportation, construction, water management, energy, and even defense. In just a decade, China has built and put into operation 45,000 kilometers of high-speed rail lines. By comparison, Japan and Europe took nearly 3 times as long to develop their own high-speed networks, and their scale is only a fraction of China's. Today, China's high-speed rail network alone exceeds the total of all other countries combined. Technologically, it has moved from importing to leading, pioneering the high-speed rail 4.0 era. The Three Gorges Dam is the largest and most complex hydropower project on Earth. The south-to-north water diversion project is the most ambitious interbasin water transfer in human history, and the land reclamation in the Nansha Islands has been hailed as a miracle of nature's craftsmanship. And among these mega projects, one is pushing the very limits of human engineering: the world's largest island-to-land connection project. From the sky, you're about to witness one of the boldest engineering feats on Earth, the Zhuhai Bridge, the world's largest island-to-mainland connection. Its 1,650-meter main span leaps across the sea in a single breath, holding the crown as China's longest-span bridge for 10 years straight. But this is just the beginning. Together with the Jintang, Taoyaomen, Shangjiaomen, and Chang'an bridges, a chain of mega bridges stretches nearly 50 kilometers, binding once isolated islands into one seamless whole. 9 years later, the 8-kilometer Yushan Bridge rose to link Yushan Island with Daishan Island. 12 years after that, the 25-kilometer Zhoushan-Daishan Bridge connected Daishan Island to Zhoushan's main island. Together with the 32.5-kilometer Donghai Bridge, which links Shanghai to Shaoyangshan Island, and the Liuheng Highway Bridge now under construction, a series of expressways have stretched across the sea, building new land right above the waves. The result? China gained the world's busiest cargo port, the second-largest offshore green petrochemical base, and its very first major fishing ground. This is not just a bridge. It's a super connection that reshaped China's coastline and redefined what's possible in modern engineering. After conquering cross-sea bridges, China has set its sights on an even greater challenge: undersea tunnels. Here, you are about to see the world's longest undersea high-speed rail tunnel, the Jintang Undersea Tunnel. Stretching 16.18 kilometers in total, with 11.21 kilometers of shield-driven section beneath the seabed, this tunnel is nothing short of a super engineering feat. Its cross-section measures a massive 14.5 meters in diameter, as tall as a 5-story building, large enough to accommodate dual high-speed rail tracks. The construction relies on the colossal shield machine, Ding'ai, with a cutter head nearly 15 meters across. Its steel blades work like the fangs of a giant beast, slicing through layers of rock and soil. Guided with pinpoint accuracy by China's Beidou satellite navigation system, it advances toward another shield machine, Yangtze, coming from the opposite direction. Deep under the seabed, the two machines will finally meet with millimeter-level precision. So why is the Jintang Undersea Tunnel hailed as the world's #1? The key lies in one word: high speed. Its design speed reaches 250 kilometers per hour, far exceeding the Channel Tunnel between Britain and France and Japan's Seikan Tunnel. By high-speed rail standards, Jintang's length and scale are unmatched anywhere on Earth. But the greatest challenges are not just about being long. The tunnel runs 78 meters below sea level, where shield machines must withstand enormous water pressure. Along the route, they face 28 geological transitions, alternating between solid rock and soft soil. To overcome this, engineers made special modifications, adding water injection pipes on the cutter head to handle sticky clay, reinforcing the sealing systems to resist extreme pressure, and upgrading the drive system for long-distance stability. Construction follows a dual shield approach. Yangtze advanced 4,940 meters from the Ningbo side. Ding'ai dug 6,270 meters from the Zhoushan side. Why the difference? Because the geology is uneven. Rock on one side, softer soil on the other, making symmetrical digging impossible. The final meeting point was deliberately chosen within a stable rock formation, the only way to guarantee a safe and accurate junction. And accuracy is everything. In an undersea tunnel, even the tiniest error in manual surveying multiplies over distance. One wrong calculation, and you could end up with 2 separate tunnels instead of 1. To prevent disaster, engineers deployed 6 Beidou satellites linked to the shield machine's auto-navigation systems, correcting deviations in real time. In the end, the alignment error was kept within just 2 centimeters. Then came the final challenge: how to remove the machines. When the two titans meet underground, there is no exit ahead and no way back. The solution? A technique called shedding the shell. The shield machines are dismantled piece by piece and hauled out, while their massive steel casings remain in the tunnel, permanently reinforcing its structure. According to plan, the Jintang Undersea Tunnel will be fully bored through by the end of 2026 and open to traffic with the Yangtze Railway in 2028. Once complete, passengers will be able to travel from Ningbo to Zhoushan in just 30 minutes by high-speed train, ending the island's long history of having no rail connection. And while officials may not say it openly, many already see the bigger picture. This tunnel is not just a passage to Zhoushan, it may well be the testbed for the Taiwan Strait Tunnel. If China ever attempts to build across the strait, this will have been the most critical rehearsal. So, just how advanced is China's technology for building underwater tunnels? To answer that, let's take the Hong Kong-Zhuhai Macau Bridge Tunnel as an example. Here's the big question. The ocean is full of water. So how do you build a tunnel beneath the seabed? And how did Chinese engineers manage to construct a 6.7-kilometer underwater tunnel 40 meters below sea level? At first, engineers considered using tunnel boring machines, But since TBMS require extremely high stability, the tunnels they dug went much deeper than the design required. That meant they needed another solution. Their goal was to build a massive sea-crossing bridge that could connect Hong Kong, Zhuhai, and Macau, a project now hailed as one of the 7 wonders of the modern world. The final solution was immersed tube tunnel technology. In this method, trenches are dredged on the seabed. Prefabricated concrete tunnel sections, called immersion tubes, are then lowered into these trenches, aligned underwater, joined together, and finally backfilled with sand and gravel. Each tunnel section is 180 meters long, weighing 76,000 tons, about the same as an aircraft carrier. Each one contains 2 3-lane carriageways and 2 service tunnels. Chinese engineers had to lower and align these massive tubes one by one, but manufacturing a single 180-meter, 76,000-ton reinforced concrete unit in one piece was practically impossible. The solution? Engineers divided each tunnel section into 8 smaller parts, prefabricated them in a factory, and then joined them into a single 180-meter unit. In total, the project consumed 330,000 tons of steel and 2 million tons of concrete, enough to build 8 Burj Khalifa towers. On the uninhabited Niutu Island, over 3,000 workers built a massive factory in just 100 days. Its only task to produce the 33 immersion tubes required at a rate of 2 per month, each weighing 76,000 tons. After more than 1,400 days of construction, nearly all tunnel sections were in place. The final piece, E30, was carefully lowered into position. Slowly, steel cables lowered the giant section to the seabed, while engineers above monitored every detail in real time. After 26 hours of precise adjustment, E30 was finally seated in place. Divers then entered the seabed, carrying out millimeter-level measurements to ensure the alignment was perfect. Once confirmed, the last segment was sealed, and the world-shocking Hong Kong-Zhuhai-Macau Bridge underwater tunnel was complete. This is not just about a tunnel. It's about speed, precision, and national ambition. A netizen compared China's rise to human learning. You get smarter from both success and failure. China is like a sponge, absorbing and improving technology. Many of these mega projects are not done for show, but to make things better. As one user put it bluntly, the US spends over $1.5 trillion on defense instead of modern infrastructure. Imagine what both countries could achieve if they worked together on infrastructure. One foreign commenter said, "These mega projects showcase China's engineering prowess and ambition, reshaping the country's landscape and connecting its vast population." But these projects come at a hefty price, often hidden from public view. The construction of these mega projects often involves massive land acquisition, deforestation, and the displacement of local communities. The environmental impact of these projects is significant, contributing to air and water pollution, habitat destruction, and climate change. Recent examples include the Three Gorges Dam, which displaced millions and altered the natural flow of the Yangtze River, and the Belt and Road Initiative, which has raised concerns about environmental sustainability in participating countries. While these projects promise economic growth, they often come at the expense of social equity and human rights. The construction of these projects has led to forced evictions, the suppression of dissent, and the exploitation of laborers. The lack of transparency and accountability surrounding these projects raises concerns about their social and ethical implications. Others see it in even grander terms. China is the first since ancient times, just sleepy for a while. Now it's returning to its rightful place. No one can stop it. Construction flows in the bloodstream of Chinese people. They have been building for thousands of years, and they're still building. The sky is the limit for China's achievements. From cross-sea bridges to underwater tunnels, from high-speed rail networks to megawater projects, China keeps redefining the limits of human engineering. These are not just structures of steel and concrete. They are symbols of ambition, vision, and determination. Of course, such projects spark debate worldwide. Some marvel at China's speed and precision, while others question the social and environmental costs. But one thing is undeniable. China has shown the world that the future is not something you wait for, it's something you build. So what do you think? Are China's mega projects a new chapter in human civilization or a massive gamble? Share your thoughts in the comments below. China has repeatedly pushed the limits of human engineering. These projects are not only transforming China, but reshaping the world. But this is just the beginning. In our next episode, we'll take you inside an even more audacious and strategic project, the Pinglu Canal. How will this canal of the century redefine the economy of Southwest China? And why did foreign viewers compare it to an alien base straight out of a science fiction movie? Welcome to a deep exploration of China's Pinglu Canal project, an undertaking so massive that it is altering the very structure of the nation. In today's discussion, we will uncover the untold stories behind this epic project, from the sweeping geographic and demographic changes it brings, to the groundbreaking engineering technologies involved, and the complex environmental and social impacts. Join China as we decode this monumental project. It not only showcases the wonders of modern engineering, but also highlights the controversies and challenges it faces. Is this massive project the solution China has long been seeking? Or is it a colossal problem yet to be conquered? China's geography has played a crucial role in shaping its civilization and agricultural development. This vast country is home to diverse terrains, from the fertile plains along the Yangtze River to the arid expanses of the north. These geographical contrasts have not only influenced agricultural practices, but also shaped the historical development of communities across the nation. Let's begin with this map of China. Excluding Taiwan and the islands of the South China Sea, it marks 55 coastal cities in China. Among them, the vast majority have played vital roles in the country's economy, trade, transportation, and culture. Yet in the southwest corner of the map, the three coastal cities of Guangxi, Qinzhou, Beihai, and Fangchenggang have long remained a hidden corner under the halo of China's coast. Despite being born with natural deep-water harbors and holding the golden key of being China's only province-level region, directly connected to ASEAN by both land and sea, Guangxi has never received the status and attention it deserves. Even today, though the Beidou Gulf port has entered the top 10 Chinese ports by cargo throughput, when people mention Guangxi's coast, it is still seen merely as a destination of beautiful beaches and affordable vacations, rather than a hub of maritime ambition, prosperity, and strength. Guangxi's sea is modest, and its rivers seem even more reserved. Flowing through it is the Xizang River, Guangxi's most important water system and one of China's busiest inland waterways. Each year, over 200 million tons of cargo pass through the Xizang, but most of it eventually flows into the Pearl River Delta. Blocked by the 10,000 Great Mountains, this golden waterway nourishes a world-class bay area, yet it has little chance to directly benefit its own hinterland. Despite being coastal, Guangxi lacks a direct river-to-sea corridor. The world is clearly close, yet Guangxi has been forced to take the long way around. This is not only Guangxi's helplessness, but also a regret for the entire waterway system of southwest China. It is time to cut through the mountains with a canal to connect rivers to the sea. The Pinglu Canal is the first canal built since the founding of New China, and a century-defining project after the Grand Canal. The Pinglu Canal is a vital part of the new Western Land-Sea Corridor. It serves as a 100 million ton level water transport artery linking the Pearl River Zhejiang River Basin with the Beidou Gulf Port. Upstream, it connects with the Zhejiang shipping mainline, known as the Golden Waterway. To the west, it extends via the Yangtze River directly to Nanning and the Zhuhai and Yu rivers, reaching into Yunnan. To the east, it flows through the Yujiang River straight to the Guangdong, Hong Kong, Macau Greater Bay Area. To the north, it connects through the Qianjiang, Hongshui, or Liujiang rivers to Guizhou. To the south, it flows out into the Beidou Gulf. The Pinglu Canal has a total length of about 140 kilometers. It starts from the Pingtang River estuary of the Shijin Reservoir in Hangzhou, about 150 kilometers downstream of the Yongjiang River in Nanning. From there, it crosses the watershed between the Shaping River and the Jiuzhou tributary of the Qinjiang River, runs through Luwu Town in Lingshan County, Qinzhou City, follows the mainstream of the Qinjiang River southward, and finally enters the waters of Qinzhou Port in the Beidou Gulf. Construction officially began in August 2022, with a planned duration of 52 months. The main structure is scheduled to be completed by the end of 2026. This new canal will become China's first major artificial canal in more than 1,400 years, since the famous Grand Canal itself. It will link the inland river system directly to the sea. This time, Guangxi's rivers will flow southward directly into the sea, rather than detouring through the more economically developed neighboring province of Guangdong. In fact, China has been considering digging such a new canal for decades. As you can see, the distance from Nanning to the Beidou Gulf is very short, just over 100 kilometers. The new canal will shorten the travel distance by 560 kilometers, which translates into about 10 days saved in transportation time. However, the Pinglu Canal comes at a hefty cost, with investment exceeding $10 billion US. Is it truly worth it? The answer is certainly yes. Water transport is cheaper than road or rail. In addition, China has adopted a very conservative approach to forecasting returns, assuming that the investment will break even in 30 years. Yet the canal itself can last at least a century with minimal maintenance costs. To fully understand the economic benefits, one must also consider the additional 800 kilometers saved if cargo from Guangxi is destined for ASEAN countries. The canal will directly connect inland rivers to maritime trade with ASEAN nations, offering massive potential. Moreover, China already has methods in place to accelerate upstream and downstream cargo transport. The Pinglu Canal is designed with 3 locks, capable of accommodating ships of up to 5,000 tons. These locks will feature smart traffic guidance through data sharing. In China, only some sections of the Yangtze River can handle such large vessels, so the designers of the Pinglu Canal have clearly anticipated and planned for heavy shipping traffic in the future. Over the past decade, trade between Guangxi and ASEAN has accounted for nearly half of Guangxi's total trade, with its value almost tripling and its annual growth rate far exceeding the national average. All infrastructure construction is closely tied to market expectations. The Pinglu Canal will promote supply chain connections across industries such as automobiles and petrochemicals. Not only Guangxi, but also provinces in central and western China will benefit from it. As China accelerates the construction of river transport infrastructure, projects like the Pinglu Canal will usher in the next stage of economic growth and social empowerment. At first glance, it might seem like just a massive construction site, bulldozers, cranes, endless concrete. But in reality, what you are witnessing is China building its first major canal in over a millennium. And it's not just anywhere. It cuts through the most rugged terrain of southern China. You may have already marveled at China's construction speed, bridges spanning entire gorges, railways piercing mountains. But this time, they are doing something different. This is the Pinglu Canal, one of the most ambitious infrastructure projects in China in recent years. The Pinglu Canal stretches 134.2 kilometers, starting at the Pingtang River estuary of the Shijin Reservoir in Hangzhou and ending at the Xinjiang River flowing into the Beidou Gulf. This final connection to the sea is the key to the canal's significance. It transforms Guangxi's inland hinterland into a potential export hub. China has a long history of constructing artificial canals. The most famous is the Grand Canal, which stretches over 1,700 kilometers and has supported the nation's economic operations for centuries. From a bird's-eye view, we can easily spot the unique characteristics of the Grand Canal. On the plains of eastern China, it is the only north-south channel among all the east-flowing rivers. It not only links up the 5 major river systems, namely Hat River, Yellow River, Huai River, Yangtze River, and Shantung River, but also connects dozens of cities along the way, including Beijing, Tianjin, Jining, Yangzhou, and Hangzhou, all by itself. And it has been flowing for the last 2,500 years or so. It transported grain from the fertile southern regions to the political centers in the north and unified the national transport system during the Sui and Tang dynasties. However, after that golden age of water transport, China gradually shifted its focus to highways, railways, and aviation, especially after the 20th century. Water transport took a back seat. For over 1,000 years, China did not build any new large-scale artificial canals. So why revive this idea now? The reason is that China's economic landscape has changed. While the eastern coastal provinces remain manufacturing powerhouses, the central and western provinces, such as Guizhou, Yunnan, and Sichuan, are rapidly developing. These regions are far from the sea, and transporting factory goods to ports like Shanghai or Shenzhen takes both time and money. The canal offers a more efficient alternative, cheaper than rail, more energy-saving than trucks, and capable of transporting large volumes of cargo. This is the significance of the Pinglu Canal, not just reviving an ancient tradition, but solving modern logistics challenges. Just as the Grand Canal once transformed internal trade in ancient China, this canal will connect China's new regions to global markets. But this project is more than just pouring concrete. It involves logistics, strategy, economics, and possibly even political considerations. Theoretically, digging a 134-kilometer canal through hills and rivers might seem excessive, especially in a country with some of the world's busiest highways and advanced high-speed rail. But this is not about showing off. It's about solving a very real logistics problem. Many areas in western and southwestern China, such as Chongqing, Guizhou, and Sichuan, are industrially dense, with factories, coal mines, steel plants, and cement factories. But they share a common problem. They are landlocked, far from the sea. Transporting goods from these regions to eastern coastal ports like Shanghai or Shenzhen usually requires over 700 to 1,000 kilometers of travel, which is slow, costly, and heavily reliant on already overburdened railways and highways. The Pinglu Canal changes all of this. It provides these inland provinces with a direct waterway to the Beidou Gulf, which is crucial for companies shipping bulk goods. Even small transportation savings could determine profits or losses. This is not only a logistical improvement, but also part of a larger strategic plan. The canal plays a key role in China's new international land-sea trade corridor, linking railways, highways, and waterways, especially connecting underdeveloped Western regions directly to Southeast Asia and global markets. Construction officially began in August 2023, with a total budget of approximately $10 billion, and completion is expected in 2026. Once operational, ships will be able to transport goods between inland factories and international ports without using any highways or railways. The canal is designed to accommodate vessels up to 5,000 tons, primarily for bulk cargo. At full capacity, it is expected to transport over 95 million tons of cargo annually, roughly twice the early shipping volume of the Panama Canal. However, building a giant canal from scratch is no easy task, especially in uneven terrain. The Pinglu Canal must traverse mountains, hills, rivers, and villages, requiring road diversions, resident relocations, and terrain reshaping. The scale of work is enormous, with extremely precise requirements. Elevation differences exist along various parts of the canal, which is why 3 large locks, essentially water staircases, have been designed. The largest, the Tantang Lock, will be the largest water-saving lock ever built, allowing large vessels to navigate steep slopes while minimizing water consumption. This is particularly crucial in regions where seasonal droughts may cause water shortages. Along the canal, there are more than 90 bridges and over 40 kilometers of excavation zones, including several deep rock cuts. In some areas, up to 13 million cubic meters of earth must be removed, equivalent to more than 5,000 Olympic-sized swimming pools. Unlike older canals, this canal is built to modern standards: reinforced embankments, automated water control systems, and integration with intelligent logistics platforms. Thousands of workers and dozens of heavy machines, excavators, dredgers, and concrete pumps operate around the clock. Coordinating construction along such a long and narrow corridor is itself an engineering challenge. Once completed, the canal will function more like a highway than a traditional waterway, efficiently handling high-volume traffic with low maintenance costs. When people think of canals that transform cargo flows, they usually think of the Panama Canal and the Suez Canal, which connect oceans. The Pinglu Canal, however, is an inland canal linking rivers to a gulf, so it does not compete with Panama or Suez in global shipping. But that is not the point. Panama and Suez are shortcuts for international shipping, while the Pinglu Canal focuses on domestic efficiency. Despite its lesser fame, it is strategically just as important for China. At full capacity, the Pinglu Canal can handle over 95 million tons of cargo annually. This is not just an impressive number, it represents a major shift in how goods flow in southern China. Previously, cargo from inland factories to coastal ports had to travel 700 to 1,000 kilometers by truck or train, time-consuming and costly. This is especially significant for heavy materials like coal, cement, grain, or steel. The canal allows goods to float directly to the coast, cheaper, faster, and with lower emissions. Some routes are expected to shorten travel distances by up to 560 kilometers, saving about a day of transport time. This is a major benefit for China's inland provinces. Cities like Luzhou and Nanning, previously far from main shipping routes, now have the opportunity to become regional trade hubs. Industrial parks, logistics centers, and export zones are already being planned along the canal. The ports of the Beidou Gulf, especially Qinzhou, Fangchenggang, and Beihai, were previously considered second-tier ports, but with the continuous influx of inland cargo via the canal, They are becoming key players in China's overall trade strategy. Nationwide, the canal gives China greater control over internal logistics. No longer entirely dependent on a few eastern megacities, the country now has new routes to transport goods to Southeast Asia and beyond. In a time when global supply chains are under constant pressure, this flexibility is extremely important. The Pinglu Canal also strengthens China's trade links with Vietnam, Thailand, and Malaysia, creating a southern trade route that bypasses Taiwan or some sensitive South China Sea passages. In short, it is not just infrastructure, it is a strategic lever. Of course, large-scale construction projects always involve trade-offs. Excavating 134 kilometers of land inevitably affects local residents and the environment. Thousands of residents along the route have been relocated and many villages cleared. The government has provided compensation plans, but not everyone is satisfied. For older residents, losing ancestral land or being forced to leave long-established communities is not just about money, it concerns identity, history, and emotional attachment to the land. Environmentally, the canal passes through wetlands, farmland, forests, and biodiversity areas, placing pressure on local ecosystems, including fish, migratory birds, and groundwater resources. To mitigate this, the government and engineering teams have implemented multiple protective measures: ecological corridors, water-saving locks, real-time monitoring systems, sediment interception, and drainage facilities to prevent erosion and sediment damage to the rivers. Experts point out that these measures require long-term supervision and maintenance, especially during extreme weather, such as floods or droughts. The canal draws water from the Yujiang Reservoir in Hangzhou, which could affect agriculture and residential water use during dry seasons. Engineers state that this has been accounted for with reservoirs and water diversion systems, but uncertainties remain under climate change. Additionally, although water transport is generally more environmentally friendly than road transport, increased shipping brings risks of higher emissions, noise, fuel spills, or cargo leakage, particularly in previously quiet rural areas. Once fully operational, the canal will not only transport goods but could fundamentally transform how southern and western China participate in global trade. Local governments anticipate the canal transporting millions of tons of cargo annually, and as industrial zones, export hubs, and manufacturing parks develop along the route, this number could increase even further. However, such ambitious plans also carry risks. One major concern is underutilization. If companies do not adjust their logistics to fully leverage the canal, it could, like other large projects, remain partially unused after completion. Long-term maintenance is also a challenge. Locks, bridges, and automated systems require ongoing upkeep, especially during dry seasons when water levels and sediment accumulation need monitoring. Environmental management is another test. Despite official promises of real-time monitoring, responding to climate change and water resource pressures will require continuous investment and transparency. There is also a balancing issue. Can the canal provide economic opportunities without causing permanent damage to the environment and vulnerable communities? This is a matter that local governments must carefully manage over the long term. Undeniably, China is doing something that no other country in the world has attempted: building a high-tech inland canal system at record speed while addressing economic and strategic concerns. The Pinglu Canal may not make headlines like the Suez or Panama canals, but it is equally important for China. This is a $10 billion infrastructure bet designed to activate inland trade, reduce transportation costs, and give the country more control over its supply chains. Construction is progressing rapidly, and China is betting on its success. If this project succeeds, the canal could become a benchmark for other countries around the world to reconnect their inland regions and reduce reliance on trucks and railways. So what do you think? Should more countries build inland canals to ease traffic congestion and lower logistics costs? Or are the environmental, social, and financial risks simply too high? Share your thoughts in the comments below, and don't forget to hit the subscribe button to join our channel. We'll see you in the next video.